Okay everyone, time for a new chapter. We're looking at chapter 8. We're going to be talking about patterns today. We're also going to be talking about relations, extrapolation, interpolation. Lots of good stuff in this chapter. But today we talk about patterns. So, what's a pattern? Well, you know what a pattern is. But it's kind of a hard thing to define, isn't it? So, here's one definition. It's a set of numbers or objects in which all the members are related with each other by a specific rule. So for example, let's start with the objects idea. Let's say I had a heart, followed by a star, followed by a heart, followed by a star. It doesn't take long until you can see the pattern, right? Going to be another heart after that, etc. The rule is that the hearts and the stars alternate. Now if suddenly an arrow showed up here, then either I've made a mistake or the pattern isn't what I thought it was, and then we may have to do some further investigation to figure out the pattern, right? So we have a rule there which, until I put the arrow there, was to alternate hearts and stars. And you can do the same thing with numbers, of course, as well. You could have all sorts of very, very complicated or very simple, like I did here, patterns. And interestingly enough, patterns are critical to mathematics. Mathematicians look for and use patterns all the time. In fact, some people actually define mathematics as the study of patterns. Believe it or not, there is not a universally accepted definition of mathematics, which can be problematic at times. But one common definition, although not universally accepted, is that math is the study of patterns. So it's super important. Alright, let's get to some questions here, and things are about to look really weird. Ready for it? Boom. So it says each number in a pattern is equal to 1/3 of the previous number. If the first number is 81, then what's the fifth number? So it gives us the first number, right? The first number, we're told, is 81, and we want to know what the fifth number is. Now, I'm hoping that you agree with me. It's going to be hard to go from 81 straight to our answer. We're probably going to need to figure out what the second number is, and what the third number is, and the fourth number, and then from there we can go to the fifth number. So why don't we do that? So let's read carefully what it says. It says each number in a pattern is equal to 1/3 of the previous number, 1/3 of the number before it. If the first number is 81, we already know that, then what's the fifth number? So as we move to the next number, the next number, the next number, we want 1/3 as much. You know what it means if we want 1/3 as much? Well, you could think of this two ways. If you want, you could think of this, for example, look at the second number of doing 1/3 of, do you remember we talked about of meaning multiplication? 1/3 of times 81. That'll work. Or the other thing you can think of if you're doing 1/3 of a number, you're dividing it by 3. So the other way you could think of it is 81 divided by 3. Whichever one of those make more sense to you, it'll work. Do 1/3 times 81, you could ninja slice this, and you'll end up with 27. Or if you want, if you don't like ninja slicing, you go 81 over 1. 1 times 81 is 81. 3 times 1 is 3. Hey, look what you ended up with. 81 divided by 3, just like I did here, 81 divided by 3. And 81 divided by 3 is 27. So that's the second number. How do we get the next one? Again, we go 1/3 times 27, or 27 divided by 3. Well, 27 divided by 3 is 9. To get the next one, divide by 3 again, 3. To get the next one, divide by 3 again, 1. So this is our answer. The fifth number is 1. Hey, what if it didn't ask the fifth number? What if it asked the sixth number? What would you do? Same thing. We divided by 3. We divided by 3. We divided by 3. We divided by 3. You go 1 divided by 3. You could divide by right as a decimal, but what's even better? 1 divided by 3 is 1 over 3. 1/3 would be your answer. But that's not what this question's asking. It's asking for number 5. So this is our answer right there. All right, I think I got 4 of them for you. What number, when multiplied by 7 and added to 3, is equal to 31? So it's not totally clear. I don't really like this the way this is stated. But what we want is some number. Okay, I'm going to write number. And you're going to multiply it by 7. You're going to do that first. Then you're going to add 3, and it's going to equal 31. Well, wait a minute. Couldn't we just use our algebra we've done before? Instead of writing number, what could I write? How about n times 7 plus 3 equals 31? Well, wait a minute. Instead of writing n times 7, what's a faster way of doing n times 7? How about 7 times n, or 7n plus 3 equals 31? Now it's an algebra question that you could go ahead and solve. You don't have to. I know before when we did algebra, I insisted on you showing me every step. If you can do this in your head, go ahead and do it in your head. But if you're having troubles, you could do your algebra. We want to get the n by itself. We got to get rid of the other numbers, the 7 and the 3. Look for adding and subtracting first. So I will subtract 3 from both sides. That leaves me with 7n equals 31 minus 3 is 28. And this is 7 times n. Do the opposite. Divide. So you end up with n, or the number, is 4. Let's make sure that works. What number, when multiplied by 7, well, 7 times 4 is 28, and added to 3, 28 plus 3 is 31, so it works. N is 4. Okay, another one. Oh, that's a good one. What's the fourth term in the following pattern? So here's the first term, the second term, the third term. We want to know what the fourth one is. We've got some A's, we got some B's. Give you a second here. I bet some of you can get this one pretty fast. Right? What's the hint? Take a look at the A's and the B's separately. If you look at the A's here, you have 1A. Then you have 3 A's. Then you have 3, 4, 5. 1, 3, 5. Look at that. It's going up by 2 every time. So 1, 3, 5 goes up by another 2, 7. Or if you want all the odd numbers, 1, 3, 5, 7. So you would need to have 7 A's. You had 1, then 3, then 5, 7 A's. 1, 2, 3, 4, 5, 6, 7. Okay, let's look at our B's. Here we have 4 B's right here. 1, 2, 3, 4. Then 1, 2, 3. Then 1, 2. Oh, 4, 3, 2. That's a pretty simple pattern. It's going down by 1 every time. So the next number would be 1. You want to have 1B. And we're done. Oh, I forgot to number this one. 1, 2. This one's number 3. This one's number 4. And this is the last one. What's the fifth number in this pattern? This is a hard one. I'll give you a second to look this over. Pause the video if you want. Impress yourself. Impress me. Tell me in the comments that you actually got this without listening to me. I'd be impressed. The first thing I would do when I was doing this one is I'd look to see, well, what does this go up by? It goes up by 6. And then this goes up by 11 to 23 is 12. That could be interesting. And then this one goes up by 24. That looks pretty good. And then this one goes up by, grab the calculator, 48. This is looking pretty promising. Do you see what's happening here? The amount it goes up by is doubling every time. 6, then 12, which is 2 times 6, then 24, which is 2 times 12, and then 48, which is 2 times 24. So how are we going to figure out how much the next one goes up by? Well, we're doubling every time, remember. Times 2 is 12, times 2 is 24, times 2 is 48, times 2, if we go 48 times 2, we get 96. So we have to take our 95 and go up 96 more. And if you do that, you'll get 191. And that is the answer. Hey, want to know something interesting? I created this pattern. I just made the question up. It's actually not the way I made the pattern up. Here's another way to do it. If I double 5, if I multiply it by 2, I don't get 11, do I? What do I get? I get 10. So if I multiply by 2, I get 10. What would I still have to do to get 11? I'd also need to add 1. Let's see if that works here. If I multiply 11 by 2, I get 22. And then I add 1, I get 23. So I'm multiplying by 2, I'm adding 1. I'm multiplying by 2, I'm adding 1. Let's try again. 23 times 2 is 46, plus 1 is 47. It's working. Multiply by 2, add 1. If I take 47 and I multiply by 2, I get 94, and add 1, I get 95. So here's another way you could have gotten this one. Pretty awesome. 2 ways to do it. I multiply by 2 and add 1. 95 times 2 is 190, plus 1 is 191. I love it. It's so awesome in math when you can find multiple solutions, and it happens all the time. And boom, we're back to this look again. Confusing, right? I won't bother explaining why that all happened. Okay, the next question is, determine the next 4 numbers in this pattern. We've got 7, 6.6, 6.2, 5.8. For what we're doing today, a lot of these questions, what you want to look for is, what's the difference? What's the increase or decrease to go from this number to this number and this number to this number, and hopefully it stays the same, in which case the rule for the pattern isn't so bad. So 7 to 6.6, what's the difference there? Well, if you're not sure, you could subtract. You could take the second one, always take the second one, and subtract the first one. Line up your decimals like this. Well, wait a minute, this isn't going to really work, is it? We've got a small number subtracting a big number. What happens there? It means it's going to go into the negative, isn't it? If you want, if we go back to our rational numbers, we could add the opposite, and yes, you do have more negatives, so our answer is going to be negative. And because the signs are different, this is a negative and this is a positive, you would subtract. But always subtract the big minus small, so you'd go 7 minus the 6, borrow from the 7, you get 4, 6 minus 6 is 0, decimal goes straight down. You get negative 0.4. That was probably way more complicated than I need to do. You probably knew it right here just by looking at it. But anyway, the difference is negative 0.4. It's going down by 0.4 each time. Did that work? 6.6 and take away 0.4? Absolutely. It gives us 6.2. 6.2 take away 0.4? Yes, it gives us 5.8. I have to do the next 4? Why so many? That's ridiculous, Mr. Wadge. So the next one, if we drop down another 0.4, what does that get us to? Gets us to 5.4. If we go down another negative 0.4, that takes us down to 5. If we go down another negative 0.4, what's that take us to? Remember, this is 5.0, so this will get us to 4.6. And if we go down yet one more, oh, I messed up my color scheme. See what I did here? Darn it. If I go down yet one last negative 0.4, we end up at 4.2. So there's our answers right there. Last one, pretty similar. Determine the next 4 numbers in this pattern. So again, when you look at this, it might look a little confusing with all these root 3's and everything. You just want to know the difference here. What's the common difference that we're going from the first one to the second one, and the second one to the third one? So again, you might be able just to look at it. If not, take either this second one and subtract the first one, or take the third one and subtract the second one. It doesn't matter. Just take one and subtract the previous one. What the heck? I'll go 3 root 3, take away the one previous, which is 4 root 3. Now, I don't know if we've talked about radicals. I don't think we've done this. This is more a grade 10 topic. So super quick lesson on radicals. You can add and subtract radicals as long as they're like radicals. Remember like terms with polynomials? These are like radicals if this bit and this bit are the same. It's called the radicand, the number inside the radical. If they're the same, then you can add or subtract, and then it just this root 3 will just stay the same as it is right now. Oh, I shouldn't have put this question because you guys aren't really ready for it. But anyway, if you have 3 of these pink things, see how it's in pink, and you take away 4 of these pink things, you now have 3 take away 4 is negative 1 of these pink things. And what is the pink thing? Root 3. So it goes down by negative 1 root 3 every time. 5 root 3 take away 1 root 3 is 4 root 3. 4 root 3 take away 1 root 3 is 3 root 3. 3 root 3 take away 1 root 3 is 2 root 3. 2 root 3 take away 1 root 3 is 1 root 3. Hey, you know what a better way of saying 1 root 3 is? Just root 3. You could put 1 there if you want, but it's better if you just put root 3 because it's simpler. 1 root 3 take away 1 root 3. Wait a minute, let me put that 1 in there just so you're clear. If it's 1 root 3 and we take away 1 root 3, what do we have now? Nothing. We're at 0. Okay, 0. And if we have 0 and we take away 1 root 3, well, we go into the negatives. We're at negative 1 root 3. Okay, don't be too alarmed if that question kind of confused you. We haven't really done these radicals yet. We haven't done adding and subtracting them anyway. So I apologize for that. Probably shouldn't have put that question. Okay, that's it. That's it for patterns today. Next day we'll get into a little more complicated patterns. Next day we won't be looking for like the next 4 numbers. We'll be looking for like, what is the 400th number in this pattern? And we're not going to be able to write them all down. We're going to have to come up with a rule, so to speak, to help us out. So look forward to that and enjoy your patterns. See ya.